Hello, good morning, everybody. How are you? I hope you all are happy, healthy, and fine at home. So, what did we discuss yesterday? Yesterday, we discussed about the factor number third one, which is nature of nucleophile. By knowing the nature of nucleophile, how to know whether the following given reaction will follow SN2 mechanism or SN1 mechanism. That are the point we are discussing. Careful study of SN1 and SN2 reaction or mechanism, we will come to know whether the following reaction will follow SN1 mechanism or SN2 mechanism depending upon the following four factors. Number one, the effect of structure of substrate, that we already learned. Number two, the effect of leaving group, that also we have completed. Number three, nature of the nucleophile, which is also we have completed. And now today we are going to discuss about the fourth and the last factor. By knowing this factor, we can easily find out whether the following reaction follows SN1 mechanism or SN2 mechanism. So look at, here is a nature of solvent, effect of nature of solvent. So here, remember, here something is here, just fourth number is the effect of nature of solvent. Other nature of solvent or effect of nature of solvent. And as we know that solvent mainly broadly divided into two types. One is called as a polar solvent and second one is called as a non-polar solvent. Among these polar and non-polar, again in a polar there is a protic polar solvent and the aprotic polar solvent. These are some of the nature of that solvent. Generally, SN1 reaction, there is a formation of carbocation, right? And carbocation, when it is possible, when there is a solvent. Without solvent, there is no formation of the carbocation, and for the formation of the carbocation there must be solvent, and therefore solvent, the nature of solvent plays very important role in SN1 reaction, because SN1 reaction taking place via carbocation, because the intermediate form there is a carbocation. If the stability of that carbocation increases, the percentage of formation of that SN1 reaction goes on increasing, or the rate of SN1 reaction increasing. Suppose there is a polar solvent is there, the rate of SN1 reaction goes on increasing. Remember, if the polarity goes on increasing, the rate of SN1 reaction also goes on increasing. So, for example, let us see here general example. Suppose we have a substrate CH-3, then CH-3, here CH-3, bromine, that is a 2-bromo-2-methyl propane, that is IUPAC name of this compound is a 2-bromo-2-methyl propane, or common name we know that is a tertiary butyl bromide, you can know that. When we are using here as a solvent is 2O, water is used as a solvent, what is happening there? There is a formation of the carbocation takes place, right? and this carbocation CH3, look at here CH3, whatever carbocation is formed over here, this carbocation is get solvated through hydrogen bonding, right? As we know that plus and there is a hydrogen, and now whatever Br minus is over there, this also get surrounded by hydrogen bonding. Here H, then O, H, so you can show like this. So this type of the thing means the carbocation is get stabilized through the hydrogen through the water molecule, means it is a solvated carbocation. This is a solvated carbocation stabilized through the solvated carbocation. Whatever living groups after departing, that become as a stable one, because that living group get stabilized through hydrogen bonding, and therefore as the polarity increases, the nature of or the rate of SN1 reaction goes on increasing. Let us see here relative rates of solvencies. Here just see, this is one of the general reaction we are going to consider here, how the rate of this reaction goes on increasing. Let us see, one table is here, relative rates of solvolysis. The relative rates of solvolysis of 2-methyl-2-bromopropane, 2-methyl-2-bromopropane, that is there, right? Now, or we can call it 2-methyl-propane, just now we have seen. And let us see here are solvent and relative rates. Here is a solvent and there is a relative rate. Now here we are going to use as a solvent. Look at the table here carefully and you come to know that how the solvent changes the rate of the reaction. Now the solvent I am taking here, first one 100% water. As we know that water is a polar in nature and the relative rate is found to be 1200. The rate of that reaction is found to be 1200. And now suppose as a percentage of that, this is a first case. Second one 50% H2O plus 50%, that is a ethanol, ETOH. Ethanol is a both are the polar solvent, but the polarity of that solvent is less as compared to as a water, because water having a high dielectric constant, whereas ethanol has a small dielectric constant, and the rate is found to be I think 60. Here is a found to be 60, and if I am changing the percentage is here is a 40% H2O and plus 60% ethanol, ETOH. The relative rate of that reaction is found to be 30. And now I am again changing the percentage of this fourth one, that is a 20% of water and 80% ethanol, ETOH. What they found, the rate of reaction is found to be 20. Now is the last one, there is a 100% ethanol here, 100% ethanol, ETOH, and what they found, the rate of reaction is a very slower one, and therefore as the dielectric constant increases, the rate of SN1 reaction goes on increasing, whereas but in this case the 100% water means here the SN1 reaction goes on increasing. Water is a more polar and it having dielectric constant D is equal to 81. So that is found in the water as compared to ethyl alcohol. Ethyl alcohol having dielectric constant is a 24 and therefore percentage of water decreases, polarity of solvent decreases, hence the SN1 rate also decreasing. This is the trend we have seen or we can infer here. What type of the information, what type of the conclusion we can draw here? If you observe this table carefully, the polarity goes on decreasing, the percentage, the rate of SN1 reaction also goes on increasing. So that is a conclusion, or we can infer this from this table. Now SN1, now remember, listen, this sentence is very important because 1 mark question always may appear in a exam. So year after year, or what we can call it as a semester pattern. Suppose this semester is this question is there, in next semester or next semester there will be a this type in a backlog or so. This type of the question appear. What is that? Listen that carefully. SN1 reaction are extremely uncommon in gas phase. What is the statement I made here? The SN1 reaction are extremely uncommon in gas phase. Listen the answer here. Because the solvation of carbocation is not possible in gas phase. Solvation of carbocation is not possible in gas phase, and therefore because in a gas there is a no water molecule, then therefore there is a no possibility of stabilization of the carbocation, and hence in SN1 reaction are extremely uncommon in gas phase because solvation of carbocation is not possible in gas phase, and therefore they are very uncommon. So that is it. Now the rate of SN2 reaction generally decreases with increase in solvent polarity in a polar protic solvent. And you know that there are two type of the solvent again, polar protic solvent and polar aprotic solvent. Now again remember here, polar protic solvent and the polar aprotic solvent. And we know that there are two type of the solvent, one is a polar and second one is a non-polar. Polar means what? There is a change in dipole moment. Why dipole moment is occur there? Due to the difference in the electronegativity, and therefore we, on the basis of that, we can easily find out polar and the non-polar. And now polar protic solvent and polar aprotic solvent. In a polar solvent there are the two types are there, polar protic solvent and the polar aprotic solvent. Polar solvent, as we know that well known example is the water, right? Water is a polar protic solvent, or what we can call it as a ethanol, ETOH, that is also as a polar protic solvent, or formic acid, HC double bond OH, ETC. These are the polar protic solvent. Remember, now is a polar aprotic solvent. What are those? Let us see here. First one is a DMF. DMF means dimethyl formamide. The name of the full form of this DMF, it is a very good example for the polar aprotic solvent. Here polar protic solvent, protic means there are the hydrogen atom present over there, but in a polar aprotic solvent there is a no hydrogen atom present. Hydrogen atom is present but not for the for dissociation purpose. Hydrogen atom are not available there, therefore that type of the solvent is termed as a polar aprotic solvent. DMF, dimethyl, it is known as a dimethyl formamide. So that is the full form of DMF, and the structure of dimethyl formamide, here is a N, then remember here CH-3, and one formyl group is there. Formyl group means aldehyde. This is the structure of dimethyl formamide, and the whatever the lone pair present on it, they can catalyze or they can stabilize the what we can call it as ion which are present in the reagent. Now this is DMF, is a polar aprotic solvent. Another one is a DMSO. Another one is called as a DMSO, means what? Dimethyl sulfoxide. This is known as a dimethyl, again dimethyl sulfoxide. So that is the full form of the DMSO, and the structure of dimethyl sulfoxide will be this one. Then CH3, S double bond O and CH3. So sulfoxide group is there, and therefore this is a structure of dimethyl sulfoxide. These are the aprotic polar solvent. There are no proton or no hydrogen atom which is acidic there, and therefore they are called as polar protic solvent. Now polar protic solvent and the apolar protic solvent, just now we have seen. Now what is happening? The rate of SN2 reaction generally decreases with increase in solvent polarity. In polar protic solvents such as water, formic acid, methanol, ethanol, etc., the nucleophile itself is solvated by hydrogen bonding with the solvent, and it is difficult for nucleophile to attack the substrate. For example, suppose let us see here, Y is nothing but as a nucleophile here. It is a nucleophile, and when you add as a protic polar solvent like as a water, what do you, or here let us see another one, alcohol, ROH, that is a polar protic solvent. What is going to happen over here? That alcohol ROH get surrounded by Y over here, water molecule. Here Y is a minus delta charge, here plus delta charge, as we know that. Then it get hydrogen atom O R or H, then O R H O R. This type of the plus delta charge and plus delta charge. This nucleophile, as we know that nucleophile are the electron rich species. Due to the presence of proton over there, that nucleophile gets surrounded by that solvent through hydrogen bonding, and therefore this nucleophile face lot of difficulty to attack on the carbocation, and therefore in a polar protic solvent the SN2 reaction rate decreases. Remember, in such cases the SN2 rate reaction decreases. In a aprotic polar solvent, for example dimethyl formamide or dimethyl sulfoxide, solvation of cation takes place and nucleophile is set free to attack. Therefore, in aprotic polar solvent, rate of SN2 reaction are very high. For example, let us see here the examples which can clearly explain how the SN2 rate of reaction is tremendously increased due to the presence of a protic polar solvent. Let us see same substrate CH-3 methyl iodide here, again CH-3 this is a methyl iodide, right? Methyl iodide, which is a primary halide as we know that, and it undergoes SN2 reaction. Now is a N3 minus, that is azide in presence of sodium azide, right? Na N3 is called as a azide, which is a good nucleophile, and that is going to attack. Here solvent is used as a methanol OH, where the dielectric constant is found to be I think epsilon maybe. Let us see over there CH3OH. What is happening here? This nucleophile get surrounded by this protic solvent, and therefore this azide is facing lot of difficulty to attack on it, and so that you are going to get N3, that is a methyl azide. This is called as a methyl azide, and the rate of reaction, rate of SN2 reaction is found to be only one in this case. And similarly here, if you treat the same sodium azide is a nucleophile N3, that is called as a sodium azide, but here the solvent is used as a DMF, dimethyl formamide. What is going to happen here? This N3 get this Na plus get solvated by this aprotic solvent, and therefore this N3 becomes as a free to attack on that nucleophile, and you are going to get methyl azide, where the rate of SN2 reaction is found to be 4.4 into 10 raised to 4. 4.4 into 10 raised to 4. This much rate is a tremendously or considerably increased as compared to this one. Here we are using, if you observe these two reactions carefully, only what is the change? Here we are using as a polar protic solvent, here is a polar aprotic solvent. In a polar aprotic solvent, that increases the SN2 reaction very tremendously, and therefore this is the thing you have to remember here. Now the mechanism of reaction might change just by changing the solvent. Highly polar and protic solvent will shift the mechanism from SN2 to SN1, and highly polar but aprotic solvent will change the mechanism from SN1 to SN2. So this is all about the effect of nature of solvent. In this way, by knowing the nature of the substrate, by knowing the nature of the living group, by knowing the nature of nucleophile, by knowing the nature of solvent, from that we can easily find out whether the following reaction, whether the given reaction will follow SN1 mechanism or the SN2 mechanism. I think with this we have completed all the 4 factors with their suitable example. Now in the next lecture we will see the comparison between SN1 reaction and the SN2 reaction, and the lastly what is that SNI, that is the third reaction. Write a notes on SNI reaction. What is the full form of that? That we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.